Iran's first nuclear power plant is located south of the Persian Gulf city of Bushehr. It took 35 years to build. When the project started in 1974 during the reign of the Shah, the German company Siemens was contracted to build 2 reactors, each producing around 1,200 megawatts of power. The 1979 Iranian Revolution halted the project. Ayatollah Khomeini declared nuclear power to be anti-Islamic. During Iran's 8-year war with Iraq that began in 1980, Bushehr was attacked numerous times, causing major damage. When the war ended, Iran tried to get Siemens to finish the plant, but the company did not return. Bushehr sat idle until 1995, when Russia signed an $800 billion contract to complete work on the facility. The single Russian VVER-1000 reactor installed at Bushehr, with roughly 1,000 megawatts power output, is comparable to its Western counterparts. Senior nuclear scientist Upendra Rochi at the U.S. government's Brookhaven National Laboratory in New York is highly familiar with the Russian reactor.
VVER-1000 is the latest Russian design, which is equivalent to Western design for pressurized water reactor. They all have same safety systems, VVERs and Western side, and they all have very good containment system.
The VVER-1000 reactor uses water for several key functions. Engineering professor Mohammed Sahimi at the University of Southern California explains.
This reactor uses water both as coolant and as moderator. Coolant is necessary to control the temperature of the reactor. Moderator is necessary in order to slow down neutrons so that the neutrons can sustain the nuclear reaction within the reactor.
In light water reactors such as the one at Bushehr, nuclear fuel heats the first or primary pressurized water circuit. The heat from the primary circuit then heats a second water circuit, which creates steam that drives the turbines that generate electricity. Bushehr's reactor is a completely different design than the much older RBMK type that exploded at Chernobyl, Ukraine in 1986. The Iranian reactor, unlike Chernobyl, is completely encased in a massive concrete and steel containment vessel. It's designed to keep radiation from contaminating the environment should an accident take place. There are multiple layers to the vessel to provide that protection, as well as strength to stop an impact or explosion from either inside or outside the structure. After the terrorist attacks of September 11, 2001, the U.S. government conducted tests to see if containment vessels could withstand an aircraft impact. Upendra Rochi at Brookhaven says the results were positive.
They found they can withstand impact of fully fueled 767 or F-4s, and the testing has been done at Sandia National Lab, and they found the penetration is only like 6 centimeters in a meter thick concrete wall.
Another important design criteria for nuclear reactors, especially in countries such as Iran, is resistance to earthquakes. Mohammed Sahimi at the University of Southern California says this was carefully considered.
The first thing that Atomic Energy Organization of Iran did was an extensive study in terms of safety of the nuclear reactor from the perspective of earthquakes. Usually a nuclear reactor is built in an area where the possibility of a major earthquake is very small. As far as I know, there is no major active fault in southern Iran where Bushehr reactor has been built.
In the next segment of this series, the operational and safety training of nuclear plant workers, including those at Bushehr, will be examined. Jeffrey Young, VOA News.